Yeah. So just to have a quick recap on what we did, the last section, not I think section 2. I actually we went through data structure, list, tuple, dictionary, sets, and I explained I explained list, I explained tuples, I explained dictionary, and I explained sets. So I expect everyone to understand the differences between list, tuple, dictionary, and sets now. So I also created a list. Remember, so I downloaded a PDF copy of the code. So I was trying to check it on the Google Colab, but it was taking me time. So I quickly use this one to explain, just for us to revise what we've touched the last class. So then we have list. I explained list method, how to use reverse sort. I explained tuple, converting to list to make some changes to that. I also explained dictionary key and value, and I explained how you can actually get the value from key. By putting the key, you get the value. I explained how to get, looping through the dictionary to get your key and value. In this case, we grab the value. And I also explained lists. Here we grabbing the list here, list item, and it's grabbing all the keys there. You can see it there. And I explained how to append to a list, how to drop duplicates using sets, how to sort, and how to pick, the first index. In this case, delete the first index. So we deleted the first index here, and we left with banana, and it made the arrangement like that in alphabetical order. Then somebody asked question on how do we now reverse. So we did that, and we also covered conditional statements, and I explained what conditional statement is all about. I gave an example of a calculator, how you can calculate and do all sorts of things. And I think the last one we did was the grade lists. So I created a mark here, and we tried to create a conditional statement for that to to assign the mark to specific grade, first class, upper second class, second class lower, and we did that, and we were able to get few things there. So what we'll be doing then, also I cover loop and iteration, how to use for loop for I in the list, and I explain all these, and I showed you example of that. And out of loop, I explained that out of loop, after going through all the lists, if there's nothing to go through again, it will print out of loop. That means it's out of what we have in the list, which is we have out of loop here. Sorry, one second. Now, I also give an example of I created a dictionary. We loop through the dictionary using items, and we grab the dictionary, the key, and the value. And here we counted the keys that we have. Here we have a day is in 3, Dorcas is 5, 1, 2, 3, 4, 5, 6. And we did that. It's just to play around to understand how we do manipulation when it comes to data transformation. So we're able to achieve that, you know. And then what else did we cover? I think we stopped there. So today I'll be focusing on, let me just do 1 second. I'll be focusing on 1 second. I have, so I'll be focusing on loop and iteration. Oh, I've covered loop and iteration. So we've covered a part of loop and iteration last week also. So which I gave an example of day, Dockers, and stuff. But I think we're going to touch few loop and iterations examples. Then from there, then we move to the next part of the class. So I'll be doing this now. Let me go through 1 second. So okay, loop and iteration. So we're going through loop and iteration today. So we done few things around for loop. 1 second. Okay. Yeah, we've done few things around for loop. So we've seen an example of loop penetration, which I showed here. We're trying to extract, you know, keys and value from dictionary, and we also did counted some made some, you know, count keys that we have in that stuff. So today we continue from there. So what we're going to be doing today is the second part of it, which is we've touched the first part of for loop. So, but we're going to be doing more or less like looping through, you know, like going through the range. For example, we have our range already. I think I've explained the range. Let's say we have, let's say range, let's say range. I think I explained this one last time, if I remember. Oh, so this is not code. Let's see. Let me just give the example of range. So the next thing is so let's run this range now. Oops. Okay. We have something at the back. Good. So this is our range from 0 to 10. This is the range. So, but we want to, the range here is equivalent to 0 to 10. So what we want to do in this case is that, why can't we loop through the range itself? So we can do, you know, based on our for loop for, let's say I like to use I in range, range 10. Can decide to use range 10, print I. So let's say we want to print I. Can you see now? So it's listing what we have here in the range. And you can see from 0 to 10. Last time I told you, when it comes to range, it's not going to count. Remember, it's range 0 to 10, so it's going to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still 10, but it's going to start from 0. So range is going to start from 0 to 10. So 10 will not be included, it's going to be 9. But when you count it, it's going to be 10. 1, 2, 3, from 0, 0 is number 1, number 2, 3, 4, 5, 6, 7, 8, 9, 10. And you know, this range is very, very good when it comes to reading columns of data. You can use range to read a specific column in the data, and you grab that particular column. You can use that And at the same time, you can also, okay, don't let me go to that level. But that is the range. So in this case now, we are printing in range. So we're doing for I in range, print I. For I in range, print I. So we can also do another stuff. We can decide to do, let's try range. Okay, there's another thing I want to explain. If we put 0 here, it's still the same thing as range 10. If I put 0 here, it's still this 0 to 10 means you can see the result there. So I can still write my range in this format to still give me the same result. So at least you can see the result here, 0 to 10. So it's still the same thing as writing 10. Just to clarify that. So we can also do, depending on how you want to do, then I explained step. Remember slicing, the slicing that I explained last time, when I was going through, when we're treating elements, we're going through a slicing, and I explained, start, end, and step. I explained that. So if you remember that, we can apply that in this case. So we can do for, let's say for I in range, we can apply that in this case. So we can do, like for example, we have range 0 to 10. We want to do a step. So let's say step 2 and put 10 in between. So we want it to print I now based on the slicing that we treated last time we touched. If I run this one, oops, something is wrong somewhere. 1 second. Did I make a mistake? Okay. Okay, let me use G. Oops. Interesting.
So I think it's begin, end, and step, but you put the step in the middle, so maybe that's why.
Oh my word, thank you. Thank you for that correction. That means someone is actually flowing with the class. That's good. Now, thank you for that. So you're correct. So begin, end, and slice. So it's taking the step like 0. So instead of 0, 1, 2, it's going to skip 1, it's going to skip 3, it's going to skip 5, it's going to skip 7, and we're going to have 8, and it's going to skip 9. Thank you so much for that. So if we put 3 now, it's going to skip 2. 0, 1, 2, then it's going to jump to 3. 4, 5 is gone. 6, 7, 8 is gone. Then we have 9. So that's it. That's for the the slicing, applying slicing in range. Then we can also change, depending on what you want, we can change the format, the way we want, the way you want it to appear. In this case, I can decide to say print. I can decide to say print the end equals to, so I want it to be, it can be in horizontal, you can make it horizontal or vertical. So I can decide to run this one like this. Then it's going to, oops. So it should that make any mistake then? Okay, we put this on. So we should have it in okay, yeah. So can you see that? So we can do it in vertical or horizontal, applying this one differently. So this will make it to turn to this format. So let's go on. Then let's say, for example, I have let's say I have okay, let me create a list now. Let's say SOM. SOM friends. So we have a list. Let's create a list. Let's say Joy. Oops. And then we have Faith, the plus. We have let's say Kenneth. We have seconds. We have no one. Right, that's okay. So we have this in the list. So we have a list that we've created already. So in this list, so I can do for maybe friends in SOM underscore friend. I can do print happy weekend. And do happy weekend friends. And do happy weekend friends. So what I'm trying to do is I'm looping through this. I'm looping through this and I want to print this. So let me try this now. You can see happy weekend Joy, happy weekend Douglas, happy weekend Kenneth, happy weekend Lawan. You see, this particular stuff is applicable to like, okay, like as a data engineer or as a software developer, you can automate your email. Let's say you have got your list of email, you know, that you've got a list of names that you want to send email to. You can decide to automate it, write a Python code and use some email API and send message to them like this with their email. You grab their email, they automatically send it to send message to their email, and it will send message to them as Happy New Year, Joy. Happy New Year, Joy. You know, for example, you will discover that your bank sometimes they send your message to you. You're wondering that, oh, they remember your birthday. You'll be wondering, but they've configured it in their system such a way that when it goes through a particular, maybe a CSV file or a database, it checks a particular a particular date that correlates, a date and month that correlates with someone's birthday, and it will trigger the pipeline to send automatic e-message. So something like that will be put in place, you know, be added, and you do that as a data engineer, you can do something similar to this. And you send message to somebody, happy birthday, Joy, happy birthday, Douglas, you know, by writing a code to, you know, to do that. So now that's an example. And if for friends in this, happy birthday, friends. If, let me do if now, let me just use if. If Ayo in friend, print, let's say print let's say no. If Ayo is in friend, okay, if Ayo is in friend, print yes. Let's say yes. Then if Ayo is not there, else, meaning Ayo is not there, print no. So let's see what we have here in this case. If, you know, we can see Ayo is not here, so we expect it to print something different. Let's say, can you see it's printing no, it's checking, because happy weekend Joy, there is no, it's not Ayo, it's no. It goes through the next line, which is Douglas. It checks, do we have Ayo there? No. Do we have in Kenneth, do we have Ayo there? No. In Lawal, do we have Ayo there? No. So if I decide to add Ayo here now, let me add Ayo here. It's going to say yes because we can confirm that Ayo is in that list. Even if it's not correct, we can decide to do dots lower. You know the reason I'm adding lower? Dot lower means it will turn your uppercase to lowercase.
Lowercase.
So in this case, because we have a capital A, it will still fail. Let me remove this. You will see it will say no. Can you see it saying no? But we have Ayo there, but because of the uppercase, it's not recognizing it as Ayo. So in order to catch that, I will just put dot what? Lower at the back. So dot lower will help us to convert everything to lowercase. And from there, you will see, okay, it said, oh, dot lower, say list of just dot lower, okay, list, okay. Okay, so, oh, sorry, there's a mistake, sorry, a mistake. So dot lower here. So put the lower here. So let's run it. It should be fine now. So can you see? It's saying what? Yes. So friends, because we've grabbed everything in the list one after the other, you pass in the lower here to turn it to lowercase. And from here we can see that we have happy weekend what? Ayo. So if I decide to eliminate this, you will see it's going to give me the actual results. It's because I'm printing that line. That's why. Can you see? No, happy weekend, Ayo. So in this case now, it's printing what? This. It's printing if Ayo in phrase the lower prints yes. So Ayo is there. But it's going through each one after the other. It's checking this one is no, this one is no, this one is no, and the other one is what? Yes. Is that okay?
Yes, sir.
Brilliant. So now, from there, we can go on because we are now out of loop. We can decide to now go to the next line because we are now out of loop. That after it has gone through all the lists and we've gotten whatever we want, we can decide to write, oh, we're done. Print. Just put a print here, meaning that the process is completed. So you can write in your code, you can write process completed. So this is what you want to achieve. So if we print it, you see, after the last one, that means it's gone through the last part of the list. That means it has completed the process. Process completed. So, that's how to do manipulation within when it comes to pipeline. So I'll be giving another example. Example that I'll be giving is let's do okay. Let me do something interesting here. Let's say we have here, let me do that's 0. Let me put 0 here. So here we have 4. So we're counting from 0. So here, so if Ayo is here, let's say we counting, I'm coming. So let me do count. So we can do our count underscore list. What we want to do here is just to keep counting, to keep adding to that particular, from 0. Our counting is from 0 here. So we want to keep adding to this. So, so what we can do is, after doing that, we can now do print count underscore list. That's out of the loop. So that will grab whatever has been counted here. So let's do this one. Let me run this one. So what I've done here is that it's going through this one after the other. It's counting the number of times that Ayo is being repeated. So in this case, we have 1. So let me put Ayo at the back again. Let me do Ayo, small letter Ayo. Let me do it again. We have Ayo. So let's do this. So let me run this now. Can you see? So here we've initialized our count list to be 0. That means there is nothing. So we're starting from the next one. Immediately it sees the first letter that we're expecting, it should count it. So for friend in SOM friends, if Ayo in friends.lower, then it should count all the Ayos that we have there. In this case, we have how many Ayos? We have 1, 2, 3. So, and I put it here, I said, if Ayo is print yes, then count. Then start counting. So when it start counting, it is counting that, okay, whenever it sees Ayo, it's going to be counting. Does that make sense? So it's going to be doing the counting here. So it sees Ayo here, number first Ayo, it will add it 1, it will add it 2, and it will add 3. Let me eliminate these 2 now. Let's see what is going to count. So in this case, let's say we should be getting 1 here if we are going to count anything. So here should be 1 instead of 3. So here, can you see is 1 because we took out 2. So let me add another one to it. And what do you see? Oh, okay. So let's run it again. It's giving me how many Ayo? Oh, it's giving me 1. So let me see what is happening there. Let me restart and run. Oh, the reason is because of comma. If you see, I didn't put comma there. So can you see 2? Can you see? So we have 2%. So he's doing the counting, it's looping through and it's doing some counting here. So imagine these are the ways you can actually manipulate data depending on what you want to achieve. For example, in your data now, you've been given, they want to, in a particular data, let's say you have last name, we have first name and last name. So maybe your data, they want to check only people that have got Ayo in their name. So you can split the first name from last name, create a new one, then you start looping through it and you count number of times that name is appearing. So it's a way of doing manipulation, data manipulation. So so that's that. So we can go further and also manipulate this to give us something interesting also if you want.
Please, I have a question.
Okay.
Please, I wanted to find out if it's okay to always do the new code on a new line of code instead of editing for the sake of the follow, so you can follow it.
You have a video, you can go through it, isn't it? Only if you are watching video, you can see how I'm changing things. But there's no different in what I've covered. It's like I'm repeating it because I'm using the same ones to explain.
So just because I'm just trying to follow this one now and I'm missing some.
Oh, you're missing something. Okay. Yeah, apologies for that. So I will follow that in the next line. Okay, so now I'm going to do maybe
Thank you.
one example so that just move quickly to what we want to cover, other things we want to cover today. Please, if you have a question, let me know so that, we can carry everyone along. But please don't go back to what we did last week. Go through the video, watch it on YouTube. If you have not subscribed, just subscribe to the channel so that you can get notified. We've got one video left to upload, which is the second section. So it's very huge, in terms of size, and I have to amend some things and upload it. So bear with us if you have not seen any notification on that. So I'll go through the next another aspect of Ismail Akinwale.
Hi.
Hello.
Hi, thanks so much.
Yeah,
Can you hear me?
I can hear you clearly.
Okay, thank you so much. I just want to make I need to check something. The if higher in Lower, right?
Yeah,
The higher you write that you have in strange is lowercase, all true. But looking at the list, we've got higher in one is a capital, right?
yeah.
What I'm looking at from if we say lower,
Sorry,
does that mean yeah, my question is if we have it as lower, right?
yeah.
Is it
Sorry,
in
you're
in
you're you are
because
not audible enough. Sorry, if you don't mind,
I'm
move
not
closer.
edible enough.
Yeah, it's fluctuating.
Okay, can you hear me now?
Yeah, it's clear now.
Okay, I'm just looking at it from different perspective. Probably I might be wrong anyway.
Okay.
But I'm trying to understand it such a way that if I'm writing it myself, I can quickly grab it. When we have French lower, and on the list we have it as there's an uppercase on the list. Does that mean French upper? Because we want to pick where we've got upper on the list. Am I wrong or something? I'm
Yeah.
just trying to
Yeah.
I'm just trying to find the logic where I can understand it better. Why we are
Okay.
using lower in front of that
Okay.
French.
Good.
Yeah.
Let me explain myself now, but I think what we'll do is that I will make a particular one upper or true. Upper. Can you see this iOS upper, right? iOS upper.
Yes,
What
yes,
this lower
yes.
is doing is that it's converting everything that you have here to lowercase.
Okay.
Does that make sense?
Okay.
So it's
Yeah,
converting
that
it to
makes sense. Convert it
lowercase.
to
Yeah.
lower.
So
Okay,
even
yes.
if we have IO here as uppercase, it's going to bend it to lowercase there so that you can see it as IO here.
Okay.
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 So
Yeah, yeah, thank you.
let me show you here. Let me show you for friends in friends. Let me print friends that's lower here. Maybe you will see what I'm saying. So here. So let me highlight this. So for friends and friends, print friends are lower. Can you see? Can you see it's turning everything to what? Lower,
Lower.
lower,
Okay.
lower. Happy
Yeah.
weekend, higher. So it's turning everything to lowercase. So is what is turning after it has been turned, that's when it's reading. It's now checking it as higher because they now match.
Okay, I get it now. Thank you. Yeah.
You're welcome. Okay. So that's the idea behind that. So there's another thing I would like to cover. So I've covered for loop. I'll be covering something called I'm trying to be very careful to use. Okay, I'll be covering something called while loop. Oops, sorry. We have while loop. So we have while loop. So we have while loop. So mostly while loop, you use it to check, how will I say now? To count through, for example, you want to count something, maybe you want to okay, let me explain. For example, you have your data. You have your data. In your data, we have, let's say, when it comes to data engineering, let me give you an example. You have your data coming, let's say, .csv file coming in, and you expect that when you read this file, you expect it to have not to be empty. So you can decide to it's not compulsory you use while loop in that case. To be honest, you can use for loop, but I'm just giving another example. You can use for loop. You can do, if maybe you can use len. You can use it to read the data frame to check what we have within the data frame if it's not empty. And if it's not empty, then you can read the file. Else, you can say, okay, file cannot be read. So, there is a way you can manipulate data when you are reading data, if data is empty and stuff. So, and also, let me just give this example. Let me give this, I think we can now start processing it together. So it can be used for infinite loop, something continuous. You know, you can use while loop for infinite loop. So you can call it infinite loop. So for your while loop, let me just give an example. You remember I gave an example of count here the other time. Count equals to 0. Let's say we have our count to be, let's say 15. Let me use 15 in this case. So we want to use while loop in this case. So I've already, you can see that that total is 15. So we can say, okay, if this total is 15, we can use y the total is greater than or equal to 0. Can you see that? So what you're trying to say is that in as much as this total is greater than or equal to 0, this one is greater than or equal to 0, then you can print the value of total. So let me just do well. Okay, yeah, you can print the value of total. I'm trying to be very careful so that I can't do infinite loop. So we can do value of variable is. So I use this in while we're doing so total. So if total is this, let's do the printing. Maybe run the printing now. And you say it's printing forever. I have to stop it. That's the reason why I said I have to stop it. So it's going to be looping forever. It's checking in as much variable is 15. That means it's greater than is greater than 0, meaning that it's going to be going forever. So it's going to count, it's going to start again, count, start again, count. So it's like you're building a system such a way that it will be infinite. Can you see it's running? That's why I call it infinite loop. Oh, is it still going? Okay, stopped. Can you see infinite loop? So I've stopped it now. Infinite loop. So, but I want to break it now. So can you see, because immediately I said greater than 0 is printing total, printing 15. It will go back again, count. If it's still 0, it will print. So it's going to be forever.
Oh, that's a lot.
That's a lot. And you know, in this case, something similar to this, I'm not teaching you something, but you know, for example, for people that attack system, they can actually create something similar to this to attack your system. For example, somebody can say you've won a lottery. Can you kindly open your email to do this? You know, when you click on that file that has been programmed in such a way, it will occupy the memory of your computer and it will shut it down. So so that's why you see how while loop works. So that's why I said it's infinite loop. It keeps going and going and going and going. So now, but we can actually find a way of terminating this. And how do we do that? Remember, we said our total is 15. So we can decide to change the value of total and start cutting it down. So I can do total equals to what? -1. So that means when it goes through, when total is greater than 0, it takes away 1 from here. So when it takes away 1, this one, the new total will be 14. So when total is 14, it will check if it's still greater than 0. What will happen? It will take another 1. It's going to reduce it to 13. And then it will keep going back and back and back like that until it gets to when it's greater than or equal to 0. When it's greater than 0 equal to 0, it's going to try to take -1, which is going to be less than 0. Then the loop will end. So in this case, now we can say now when the loop ends, we can now do out of loop. Let's run it and let's see the results. Can you see? So it's going back when the total is 15. Why this total, which is here, is greater than or equal to 0? 0 is greater than, when total 15 is greater than or equal to 0, it's going to be this. So 15 is greater than or equal to 0 until it gets to 0. Can you see? Immediately it gets to 0. Now we know that total can be equal to 0, but it cannot be less than. So -1, when it's -1, immediately it gets to that 0, and you are taking 1 again, it will just say out of loop. So this is the kind of way you can stop a loop. So, but when you put the loop and you don't put, if I put +1 here, it keeps going forever. So it's going to be adding 16, 17, and for you to, before you know it, we'll be counting billions, trillions here, and it will go forever. And to limit that, that's why I put -1 here, so that it will go back. It will be subtracting 1 from it, one after the other, 13, 12, 11, 10, 9, 8, until it gets to what? 0. Then it goes out of loop. So that is an example of while loop. So you know, I've explained this. You could use this one to, to attack a system, but and it's not good. Please don't try it. But in order to limit this so that it won't go forever, we've added total -1 so that can stop the loop, and it's going to print out of loop, because at this point it's going to check when total is 0, -1 is going to be -1, and -1 is what? Less than or equal, is less than 0, but we are expecting it to check greater than equal to 0, if I'm making sense. So that's that. And also we can also use while loop in another way. Let me give an example. Let me give an example here. The example is, let's say, for example, we have n equals to 25, let me say 74. N equals to 2574. And like I've shown you an example of count. So let's initialize our count to be 0. And let's say y, we want to check why n is greater than 0. In this case, we say n total is greater than equal to 0. So we want to say where yn, our yn is greater than 0. What we want to achieve here is that we want to do a kind of remainder. For example, we have, when you are doing remainder, let's say 2 divided by 2 is remainder what? Please, can someone give me an answer to that?
0.
Remainder 0, thank you. Remainder 0. Remainder 0. If I say 3 divided by 2 is remainder what?
1.
1.
Brilliant. So if I say 4 divided by 3, remainder what?
1.
1. Brilliant. Because 3 will go in 4 only once, and it's going to remain 1. So it's going to be 2 divided by 2 is 1, remainder 0. 2 divided by 3. So use 2 to divide by 3. So it's going to give us 1, but remainder 1. That remain 1 to remain 1. Then 3 divided by 4 is going to be 1, remainder what? 1. So we want to catch the remainder in this case. This is what we are interested in. We want to catch the remainder. We want to catch the remainder. So now let's do something interesting here. So in this case, I want to see if my remainder, let me say, I'll call it digit, equals to, let's say, n, and remember our n is 2574. So n, let's say, divided by, don't forget, is the remainder we want to calculate. Division sign is different. So this is to catch remainder. Remainder, to catch the remainder here. So let's say divide by 3. Then I can do, if our remainder, we want to catch the remainder and start counting them one after the other. I've shown you an example of how to count. So if our digit, that means the remainder here, either remainder 1 or 0 or whatever that we have. If this digit equals to, this helps to catch the integer. So let's say equals to 0. Let's say or digit equals to, so all means is either, not and. You know, when you are using and, that means you want to have both results at the same time. If you are using or, is either this or the other one. So let's say remainder 1. Let's put remainder 1. So I can do, remember we've initialized our counts here. Our count is starting from 0. If you look at it there. So if this, then start doing our counting. So I can decide to do counts and do count equals to count plus 1. So it should keep counting. And otherwise, we can also apply these counts. We can do it this way. So it can be what? Plus 1. So instead of you using this, you can decide to write your count as this. Count. Either of the two is going to work. Does that make sense? So now, so let's use this one. They are the same. If you use this particular method, it's the same thing as this. So let me use this. But I will try it one after the other so that you see that they are both correct. So you can decide to do count equals to count plus 1, or you can do count plus equals 1. Still going to give you the same results. So now let's do something interesting. So we're doing our count. So whenever is this, let's say print, let's print count. One seconds. Let's print our counts. Let me run this and let's see our results. Oops, can you see it's going forever? It's taking forever. So let me stop it. And you see it's like infinite loop again.
Yeah.
Can you see? So because of the y. So, but what I want to do now, I want to limit it. So how do I limit that? And I will teach you how to limit that. So it's taking forever, forever, forever. So I've stopped it now. Good. Now, because we keep adding 1 whenever it sees that is, is either 0 or 2. So it keeps seeing 0, keeps seeing 0. Then it keeps going back to this one, and it's counting forever. So now let's go. How do I now limit this? So we have already our count. So I can decide now to do this count now that we have that is taking forever. I can't now. Sorry, the count that is taking forever, I can limit it by, for example, keep dividing my hand. So first, let me change this one to 10 so that I can get more division. So let me choose this one as, okay, let me do that. So let me say divided by 10 so that I can limit wherever we have. So let me print this count. So I'm not going to print the count here. I'm going to print the count after this stage because now we are out of this if statement. So it's doing a new calculation here. So it's not going to make use of this n anymore. It's going to go through this one after, just like the example I gave here, and it will start counting. So it's going to divide this and it's going to start counting. Let's see. Can you see? So it goes through here, 2574. It sees that it's greater than 0, and it finds the remainder. When it's going to go through this one, remainder, this is going to be 0. If it's 0, then it's going to count. So when it counts, does that make sense? So when it counts, it's going to take that n, this value of n, and divide by 10 again. 257. Does that make sense? So it's going to be doing it and be looking back until it goes back to 1. Am I making sense? It's going through here. Look at it. Here we have digit equals to 0 and digit equals to 2. So it's going to check here, number 1. When it does the division, it's going to check. If we check this one, 10 divided by this is 0, isn't it? 10 divided by, 10 divided by this, it should be 257, goes 0, okay? Then that 0, when it goes that, checks that, it's going to add 1, okay? So then we have, the next stage we said or 2, so or 2. So it goes through this again. Oh, I'm sorry, 1 second. Let me use another very huge amount of value. It's taking forever. So double division, sorry. Yeah, let me do it this way. Okay. So I'm coming. So I've shown you an example of that. So what this is doing is just it's dividing this and taking it down. Why is taking it down? So this goes back here. So after dividing here, it will go back here again and another division will take place. Am I making sense? So another division is, I will tell you what is happening here. So look at it this way. We have here, after the division, let's say 10 divided by this is going to be 257.4, right? Then that should give us remainder 0, right? If I'm correct. Then when it goes through that, then it will check the remainder. Okay, let's do something interesting. So we have 10 here. Let me use 2. Or let me use 5 to limit it. Let me use 5. Let's see. So if I use 5, and I use 5 here. Okay, good. So it's doing the counting now. Better. I think this one makes sense. So what it's doing here, it goes through here. It checks if this is 2574. So when it's 2574, it's greater than 0, then it's going to put that 2574 here, divided by 5. So we can do the calculation from our side. If we have a calculator here, let me see if I have a calculator. I have a calculator here. So let's put it side by side. So we have here, we have 2574 divided by 5.
514.8.
514.8.
4.8.
Okay. So this one, I don't know why it's giving me. So it's 514.8. Remainder what? That's remainder 8, right? If I'm correct.
Yes.
So can you do 514 times 514 times 5? So 514 times 5. Can you see? Remainder 4, right? It's remainder 4. Because 257 remaining what? 4. Am I making sense? So it's remaining what? 4. So that 4 is not in digit 0. That's why we see 0 here. And it's not 2, right?
Yeah.
Brilliant. So now that means it's not there. So it's going to give us what? 0. Then it goes further. It goes to 514. 514 divided by 5 again. 514 divided by 5. So it's going to go through by 102. Let's do 102 times 5. 102 times 5. That's what? 5, 1, 10. 5, 1, 1, 0, right? So remainder 4. So 4 is not here, you remember. Remainder 4. 4 is not digit 0. It's not 2. So it's going to be what? 0. So we have 102 left, right? So that 102, so if we divide 102 by 5 again, 102 by 5, 102 by 5,
20.4.
20.4. So remainder what again?
Remainder 2.
That too.
Remember
Okay.
two.
Okay, so 1 second, 1 second. So remember, it's going to, after getting to 105 here, and there is a division here. So this division will reduce it, and it will take it back here. So in this case, so we have 220 multiplied by 5, remainder 2. So at that stage, it's going to be what? 1, because you can see remainder 2 here, isn't it? Does that make sense? Does that make sense? Remember, we did the first calculation, second calculation gives us 0, 0. Next stage is what? 100 divided by what? I'm sorry, 10 times 20 times 5 is 100, and it's already 102 in that stage. So that 2 at the back is remainder 2. So that remainder 2 will give us this. So we have 20 left. So let's do 20 now. 20 divided by 5. 20 divided by 5 is what? Remainder what? 0.
Zero.
So that means we have 1 already. So it's going to add the new remainder 0. It's going to add it to that count. It's going to be what? 2. So at this point, 5 now. If we do 5 divided by 5, what is it?
0.
Zero.
1.
Sorry?
1 remainder 0.
That's remainder 0.
You remember, it's going to divide this and take it back as divided by 5 again. Which is what? So that's 0 point, I'm coming, 0 times 5, 0. So remainder 0, right? So that's how the calculation is working out. So it goes through each stage, it divides it, takes it back, find the division here, takes the remainder, check if the remainder is 0 or 2, and it will be counting like that. So that's how it works. Now let's go to the next one. Please try this one on your own. Choose any value and start doing the calculation. Please don't just run the code. Use your calculator to do the calculation and see how it works out, how everything is being counted. When it's not there, it's not going to add anything. If it's remainder 0 or 2, it's going to add 1 to it. If it's another remainder, it's going to add another 1 to make it 2. At this point, it's not adding anything, stopping at what? 2. That's the limit. Does that make sense? Because remember, we've already said n must be greater than what? 0. We've set a limit, n must be greater than 0. Anything less than 0 is not going to catch it. So here is looking for the old 0 here in this case. So let's go to the next one. Okay, let's do this one together. Another why this one is you use they call it break statements. Break statements. So mostly in your code you can apply break. You can apply break. And the reason why you need to apply break is that in case of any, let's say for example, you have any failure in the code, maybe something that you want to catch let's say is a bug in the code, you can use break to stop the process from continuing. You use break to stop the process. So for break statements, I will just create an example here. So for I in, let me use for I in So for I in, let's say for I in 10, let me use 11, let me use 13, 18, 20. Let's say this is what we're interested in. So for I in this, then I can say if I divide I by 2, I want it to give me a particular remainder, so that you can understand the remainder, so that it won't be strange to you. So if I divided by 2 is going to give us remainder, let's say remainder 1. So let's say it's going to give us remainder 1. Then I want it to break. I want to apply break. That means it should stop the process, exit, the process. So then from there, you can now print the last, the last process in that, for that I. So let's say they'll be able to catch including the last process for that I. So let's run this one out. Let's say for I in 10, 11, 13. So if 10 divided by 2 is remaining 1, 10 divided by 2 is what? Is it remainder 1? Is remainder what? 0.
0.
So that means it's not going to break, right? So, but here is what? Remainder what? 1. Does that make sense? It's going to break. Let's see the process. So we're expecting everything to break here, and it should not continue the other part of the process, the list. It will not loop through all the list. So let's see. Can you see? So it's checking here for I in 10. So we have I is 10 here. 10 divided by 2. I want to calculate the remainder. 10 divided by 2 is what? 5 remainder what?
5.
Remainder 0. But we want to catch remainder 1. So it's going to print 10 for us, right? Hello? So
Yes,
now what we want to catch is when it is remainder 1. So in this case, it's remainder 0. So it's not going to read it, right? Because we've put our statement here that only if it's remainder 1. So it goes to the next stage. That's 11 divided by 2. Remainder what? 1. Break. So when it breaks, it's going to print. It's going to stop here. So here is printing only the first one that is not it's only printing the first one that does not obey this law. Let's say, for example, now let me change this one to 12. You see, it's going to print 12. But when it gets here, it's going to stop, because we've already set a condition that if it sees that anything that will give remainder of 1, it should what? Break. So it should print it. In this case, it's going to print 10. It's going to print what? 12. Let's see. Can you see? So it's going to print that. Let me take this 13 out of the way, and let me put it as the last value. Let me put 16, 14, and now put 13. You see what's going to happen. When it gets to this 13, it's going to break. Let me put 22 at the back. So here, in this case, because we've set our condition that when it's you do the division and it gives you remainder 1, it should stop, but it must not print it. So can you see? It's going to go through 10. 10 divided by 2, remainder 0 is not remainder 1. So it's going to continue the process. It goes through 12, 18, 20, 16, because they are all even numbers, right? Anything in even numbers will not give you any remainder. Odd numbers, anything you divide, if you use 2 to divide odd numbers, is going to give you remainder what? 1. Every odd numbers. So for even numbers, for odd numbers here, surely it's going to give us what? 1. Because if you use 2 to divide odd number, it's going to give you remainder 1. So when it gets to this stage, after checking through the even numbers, where you have remainder 0, then it will stop the process here. So that means the process is perfect up to this level, but when it gets to the even number that you are not expected within the code, it's going to what? Stop. Does that make sense? So this is a break statement. You can use it. You could use it within your code to do a lot of things. And after that, you can say, because now you have reached the end, using that break, you can say print process stopped. or process, like I said the other thing, process completed. Process completed. Process completed. You see, sometimes when you run some things, you see dot, 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 at the back. Process completed. So that's the idea behind break. So it helps you to see, okay, if there's any failure, please, if you see this form of failure, maybe error within my code or while you are running the process, please break. It could be like, for example, you're looking through a data and you could see that, oh, there is a missing value somewhere. You wanted to catch that missing value, or maybe the data is empty. It should what? Break and stop the process. Or for example, you are reading a data frame and the data is empty. You can say it should stop. It should not loop. It should not go further to read other files anymore. In as much you can see the first one, it's seen that the first one cannot be, it's not readable. So it will stop. It will just break before then it will stop the process. So it will not continue the process. Now, there is something called handling exception. So I think we can't get into the end of this section. So something called handling exception. So exception statement is very, very good. And why I said it's good is that it helps you to catch error in your code of kind of failure also. So this one will stop. You know, in this break, the process will stop. But in this case, even when the process is going to stop, it's still going to catch the error and tell you where the error is. So you can quickly, get alerts, and from there you can fix that particular error. You know, when writing code, when it comes to software development, it's not actually completely free of error. For example, you could see some users, uploading maybe wrong files, because I've worked in, in different, different work environment where you, please, can you mute yourself, please? So in this case of handling exception, so exception will help you to catch any error in your code. So there's something called try and except. So use it to catch and, undo some exceptional cases in your code. So we have the normal part of your code that is working. In case, okay, let me give you an example. Let's say we are reading, let's say, like we said, spark.read, let's say spark.read.load, the other time. And we decide not to upload our CSV file in this environment. If we are reading that, it's going to give us error. But in this case of handling exception, this exception will catch that error and it will read it. So in that case, when you read this exception and read this particular error, you can decide to catch that error and notify people that are concerned about that particular area. I mean, the users. Let me use the right one. You can notify the users that, okay, there's an error here. Please go back and fix it. There's something called monitoring tools. So using this handling exception, this will help you to catch any form of error, and you can create like a monitoring tools, like a code, especially in the cloud environment, or send email notification to users or the developers, or even you yourself, to know that, oh, something has failed here. And the benefit of this, it will help you to quickly discover what's actually happening within the code, where the error is coming from, how to fix it. So it helps you to track any form of error. So I always advise, when you are writing code also, you should try and use handling exception, this particular exception within the code, so that could actually get the error, catch the error as early as possible, and get notified, then you'll be able to fix that particular error. Imagine you've written a very lovely code, and at the end of the day, just because of error, the system failed as a result of not handling this exception, and you're struggling to trace where the error is actually coming from. That could take you like maybe a 2-3 days to be tracing that error within the code. But with the handling of exception, you could actually trace this thing easily and just so, oh, okay, this is where the error is coming. Within 5 minutes, then you get everything fixed. If it requires you to modify your code to catch the bug within the code, because this handling exception will help you to catch the bug. It will help you to catch bug. What do I mean by bug? Any form of failure that you have not added to your code. You know, in some cases, you have a situation where you write a very beautiful code, but you have not really included another something you didn't know that something will happen that will break the code. So you quickly, using the handling exception, the handling exception will catch that. I was like, oh, okay, this is an error. Okay, let me go back to my code and modify it to, you know, for the process to work fine. So it's very, very good to use this handling exception. So we have something called try, and we have something called except. So try, except. So you need to apply. So for the try, your main code that you're writing, for example, in this case now, my main code will be here. Try here. Does that make sense? So my main code will be here because this is my main code. Can you see? This is my main code. Except will be here. Except we just help you to catch the error. So this except is like, if there's any error in this code now, it will tell you, you can say except and print, let's say, for example, let me use something different. Let me use. Can you see that? So you can also use, let's run this one. Let's see if there's any issue with this code. So it's not going to catch that. Can you see in the code, everything worked fine, right? Does that make sense? You see, it worked fine. And you see, what's the exception here? Let's see the exception here. Can you see it's printing the exception for me? It's even catching the exception here. Look at this code very well. Let me see, 1 second. Here, we didn't catch this. But in the next stage here, when I apply this, you were able to catch the what? 13 here. So let me do, okay. Let me do here, let me take this off. Let me do exception E. Okay. Let me do print. Let's see. So we want to print the class of the error. So we have this class. For this error occurred. So let's see, let me run this one now. Can you see? So I'm expecting something. Okay. In this case, it's not saying error. So it's just printing here. So if this is with is printing this and is breaking. So it's printing this, and the reason why it's printing is because it's outside the loop. So if I do this one now, I don't know if you're getting what is happening now. If you remember the if statement, print here, I put it under here. So because here we are out of it, so that's why I'm getting only 13. So here, can you see it's printing wherever I have here. So in this case, there is no exception. So let me do print I. Let me do if I'm going to get this exception. Let me see. I think I should be able to get this exception in. Oh, it's not printing it. So it's just stopping at 13. Print this. I'm expecting something to happen, and I don't know. Oh, okay. So you know why it's printing 13 here? The reason why it's printing 13 is that 13 goes with remainder. That's the only part. You know, I didn't put break here. So in this case, I'm putting 13 here. So 13 divided by 2 is remainder 1. So print 13. So anything outside that loop, outside that print is going to print any other stuff that we have. Can you see now? So if I exclude this one, it's going to exclude 13. Can you see it's repeated twice? So this exception itself, sorry, there's another. Oh, am I getting it? Sorry, 1 second. Just want to check the code itself. Okay, it's expected to be there. So now, so the exception here, what it does is that if there's any error within your code, it's going to catch it. That is the except aspect. So except as you can modify the code like this, except exception as E, except exception as E. Does that make sense? So let me see what I can do. I think I've not been able to give more clarification on this. It's not really clear, but let me use another example. Let me use a very good example. But just know that when you're writing your code, your main code that is correct will be in between try here, in between, just like we have here. Then we have exception to catch any error within this code. So the assumption here is like your normal code that you have written. For example, you've written a very beautiful code, you just put exception here, and suddenly you didn't get any error. And maybe after some months, an error just came in. Now, this will help you to catch that error. From there, you can modify your code. So I'll go to maybe, I think, a better example here. Okay, let me give this example. Let's say let me give an example like this. Okay. So we have, let's say we have a random, I'm creating a random list. Let me create a variable random list, and I'll call it like, I just put 10 to 3 B, let's say C, 8, just put any number inside, and let me say D. So in this case, this string, let me produce a string. So that's integer. So we have integer there, we have string there. Oh, this one is also string. So let me initialize what we have here. Let's say I'll use total. Let me use one initialize at 0. Let me count 0. So let me see. I can now say for let's say our list in random list. Okay, from array in random list, brilliant. So I can now put try. So let's say we have okay, so we have, I think this is a very good example. So let's say we want to print, let's print our entry here. So let me put except at the bottom. You remember try and what? Except. So let me put it here, try and except. Like I said the other time, I said your code will be in try here. Your main code will be in try, except it's just to catch the error. So I'll put it that way. Then I can write print, let's print wherever we're expecting. So let's say entries list. Oh, okay. So let's do our list. So we have our list. Then from the our list, I want to do, remember, I want to do something interesting there. So we have run total. So our run total, I can say equals to run total, like I did the other time, run total. So I want to add the our list here. So remember, we are integer. And when you are using addition, you'll be using it. When you are using, want to add something together, you can use int to convert it. You use int to convert it. So this int will help you to convert wherever you have, but in this case, we have string here. So we should be expecting something interesting to happen here. Because we want to use int. That means it's going to fail when it gets to this. When it gets to this. So it's going to fail. So now, we've added this one now, and we have our exception. Brilliant. So this is a very good example where you have integer here, but we want to add, this one is 0. We've initialized it as to 0. So 0 plus any integer that is coming in will give us a result, right? So now, in this case now, because we are in the exception, sorry, this is not correct. Let me adjust it very well. Wow. So let's say, let's print our total here. Let's say print total outside that exception. That's the result we want to catch. So we have the run total here. So we have run total. Run total is run total. Run total. Brilliant. So now, then we can catch the error there. It's okay. Then we can catch the error. We call it error there. I call it error there. Okay, so now let's see this example. This is a very good example. So now we're looping through this list. We're looping through 10. If we do 0 plus 10, it's going to give us value, right? Now, when it gets to B, it will say 0 plus what? Integer B. B is not an integer, so it's going to throw an error. Does that make sense?
Yes.
Do you understand what I mean? So immediately it's looping through. It goes through this. After it goes through that, it will check this run total, which is 0, plus integer. So the integer is our list. Our list is what? Our list is a random list, 10. So it's going to have 10 plus this, going to be what? 10, right? Does that make sense? So it's going to be 10. So when it's 10, it's going to go to the next one, 2. Does that make sense? So it's going to count here 2 again. So it's going to do 10. Sorry, 0 plus 2 again. Does that make sense? So immediately it gets to B, it will see that B can never be an integer. Can you see? You know, immediately we printed B here. Then it says, oops, class value error.
It's not an integer.
Because it's not what? An integer. Because it's not what? An integer. So it's going to what? It's going to catch that error. So in this case, it's telling us that, oh, this is not an integer. It goes to the next one. When it sees C, integer of C, sees that, say, oh, oops, value error occurred. Then it moved down to 8. For 8, we're able to do it successfully, right?
Yes.
But immediately, after getting to D, what happened? It says another error. And what did it say now? It said round total is what? 23. How did we get this 23? 8 plus 2 plus 3 plus 10. Because it keeps adding them all together to give up. Does that make sense?
It does.
So let's say, for example, now we want to count the number of errors that we have seen. How many errors do we have here now?
3.
We have 3 errors. So, but we want to know the number of errors. So in that case, we can now grab the errors. Remember, we've already stated here error. We've initialized to 0. So we are doing the error here, and we are grabbing the error. We are grabbing them one after the other. So the first is 0. So immediately it sees an error, it's going to add 1. Then if it sees another error, it's going to add another one. Then let's run it now. What do you see? How many errors? 3 errors, which is this. Does that make so? Because this exception case is trying to tell us where the error is coming from. Does that make sense?
It does.
Yes, thank you. So in this case, with the number error, I want to see what I can do here. Just let me see if it can give me that. And you see, it's giving us D because I added out list. So it's showing us the last one now. In this case, it's trying to tell us this is where the error is coming from D. Does that make sense? So here, if we don't have this, we won't get this error. Don't forget, if we don't have this, let me remove this. Because they are all integers, right? Let's run it. Oh, okay, nice. Can you see? Okay.
Yeah, 2 commas.
2 commas. Can you see? Is it showing any error?
No.
It's not showing any error. It's not even telling us if there's any error somewhere. See, there's no error, 0 error. The reason is that we're able to run this one successfully because there is no string there. If I add string again, it's going to see the error. It's going to catch. Can you see? Oh, value error. So it's reading that those ones are string because you can't add string to number. So it's going to see it as what? Because we've already indicated that this should be integer. So it's going to give us an error. Does that make sense? How to use exception now?
Yeah, it does, sir.
Yes. So that's why I decided to give another example here to tell you that if we add integer here, if we add string here, we're going to get error. But if it's only integer, sorry, if it's only integer here, it's going to, can you see the errors? All the errors are gone because there's nothing to read here. It's not under exception. They are all correct. So in case you make any mistake or your data is coming wrongly, this particular exception as if will catch that error and it will tell you the type of error. In this case, it's telling us it's a value error. Let's go back. Can you see? It's saying is what? A value error. Is what? A value error. That means it's a value. So we're having problem with this. So it's telling us with this exception as E, this E is catching that particular error, what the error will look like, as it looks like. So what the error looks like is what? Value error. So it's talking about value in this. So you are now saying, oh, this is B. Oh, I shouldn't have added B. Let me go back to my data and manipulate the data and put wherever it should be there. Or in this case, maybe you have to modify your code. You understand? And say if this is, is a string, you understand? You want it to append it to another. I don't know if I'm making sense. So you shouldn't make it as string anymore. So in this case, you can decide to say for this in this, if there is something called a string. So you can just add that one to catch it as a string or as integer. Then you manipulate your data and you do the normal process within your data. So it will help you to, remodify your code to catch that error and maybe get wherever that is coming there. Then you add it to your data. So that's how it works with exception. Any questions so far? Is that straightforward? Please, if you have question, please ask question now, because we're going to have a quick break, and we'll come back and continue with other aspect of the work, the project, and the lecture, the training rather. So we've covered some things that we need to do within Python. So now what we are left to do is to start applying a few things that we've covered using Python while we are doing data transformation with Spark. So thank you so much. So I'm going to pause this section now.
Sir, we can't hear you.
Oh, yeah, thank you for that. Can you hear me now? Sorry.
Yes, we can.
So we're going to start with Spark. I'll continue from where we stop with Spark. So I'm not going to go through this again because we've gone through it together. So I think everybody should be fine to run, to download Spark, to unzip then to run the process up to this. I told you if you want to run it, that's fine, but you can also upload file from here. You can upload file from here, which I showed everyone how to do that. Okay. So I'm just loading, so SOM 17, let me 17. So I'm going to be explaining a few things. Now, you already understand how to, run Spark from PySpark.sql import Spark section. Then you can do Spark section, builder app name. For this one, I use SOM 17. So what I want to do next is to create a column. Already, when it comes to I'm coming, let me so when it comes to reading data, which I believe you're all familiar with, we have data like this. Oops. We have data like this. So we have this data now. So this is column, which is like key, our key. Remember, we've been talking about keys, key. So key, we have value inside the key. So this could be like a form of dictionary. So we have the key and the value in the data. Values here. So, and you can use for loop to loop through all the rows and check and make some changes within the data. So that's that for to fit column one. Okay, so that's that for that. So here we have LA name, LA code, middle name, children, this. So I want to create something similar here. I want to create something similar just for me to introduce you to how to manipulate data when it comes to Spark. So here we want to create a column. This is the list of the column. So we have the list is LA, the list elements in the list are one, LA underscore code. We have middle underscore age. This is the element. So then we have our data. This is our data now. Can you see our data here? So it's like you have a tuple in the list, right? If you see it, the way it appears. So we have in each row, we have two columns. So for each column, I think it makes sense if I explain this way. So look at this. We have here, in this case, we have E00. So I call it LA code. So this is the column, this is the key. These are the keys. We have LA code and middle age. So I'm just using these two only, please don't forget. So I'm creating it manually. So I'm trying to describe what is happening here. So when you compare to this. So what I'm trying to do here is that I'm creating a tuple in the list. And in this case, we have a string, an integer, string and integer, string and integer, LA code, string, middle name, integer. Can you see? So I'm only using this. It's like I'm deleting. If I want to compare to this file, I'm deleting this and I'm deleting this. I'm only going to be running this only. So that's what is happening there. So let me minimize this so that you understand. So for the columns, I'm creating a column, which is this. Then I'm creating a value for that particular column. We have values here, which is data underscore value. Then from our Spark data frame, there's something called Spark context. So you can get from Spark here that we have Spark section builder happening, Spark context dot parallelize, and you pass in a data underscore value. And what I'm trying to explain here is that in Spark, there's something called RDD and there's something called data frame. We have RDD and data frame. So from Spark section that we have here, we can use RDD there and start transforming data using RDD. We can convert from Spark RDD to Spark data frame. So in this case, we have RDD equals to Spark context dot parallelize, which is a function inside the Spark context, a module that then we have data value. The data value is the value that we have here, and we pass it inside here. So if we run this, we have our RDD. That's why I wrote this is RDD. Let's run the RDD. See, so that's the RDD dots. Let me just connect. It's going to show it's not showing the value. Okay. Okay, so
RDD another library or something.
yes, remember, yeah, it's from Spark also, but we're getting it from our Spark here. Spark equals to Spark section builder dot happening. Let me take you back to can you see RDD? In our Spark library, we have RDD. So if you go here, if you go to Spark here, there's something called RDD. We have data frame. Can you see? Spark Streaming, Machine Learning Library, PySpark, Python on Spark. Can you see the details there? So I'm trying to explain part of Spark, which is RDD. So let's see what we have here.
Go and meet your sister.
Okay. One second, please. So now, this is RDD. Look at this. RDDs, Spark revolves around the concept of resilient distributed data sets, which is fault tolerance collection of elements that can be operated on in parallel. There are two ways to create RDDs: parallelizing an existing collection in your driver program and referencing it. So this is the RDD I'm talking about. Look at it. I was trying to give an example of this, and I'm passing the data here. So this is what we have, sc.parallelize. In this case, say sc.parallelize. So you can read test file using RDD. You can do a lot with RDD. And you see sc.parallelize and stuff. But I'm not taking you through RDD. I'm taking you through the data frame itself. It's like an improved version of Spark. So data frame is an improved version of Spark because within data frame, you can do Spark SQL, you can access pandas, you can do a lot within that space. So for the RDD, now, if you see what I showed you the other time, I have this part, the Spark context is SC, they call it SC dot parallelize. If you see it, we have SC, what is it? Sorry. If you see here, we have SC dot parallelize, right? This is similar to what I just did here. SC dot parallelize, parallelize, and I pass in the value, which is the data. And when you pass it in here, then you can read, you can convert this RDD. Look at, let me go back here now. You can convert this RDD now, convert it to data frame. So you can convert your RDD now, RDD to DF. There's something called to a DF in data frame. So here we can convert RDD, which is also Spark, to data frame. If we run this one now, we can convert this one and we see the results. So it's loading. Can you see the result now? So here, what did we do here? We added the columns here. See the columns that we created? We pass into that DF as a column name for this to get, our data frame. If I don't add it as column, let me run it. This is not going to show anything. It's going to show no header. Can you see the header? It's just giving it a number, random number. But if I pass in that column name there, columns, I will be able to get a column name. So you can convert your data in RDD, you can convert it to data frame and start doing your work. You see, there you can work hand in hand, convert your data to RDD to data frame, and start doing transformation, take it back to RDD. You can do whatever you want to do within your code, depending on what is comfortable and convenient for you. So another way to read data frame, okay, we have print schema. Let's print the schema now. In this case, we have two schema, ls code, read, and one is string and the other one is what? Integer. So in Spark data frame, integer can also be double, but it's also integer or floats. This one looks like floats, but because of dots at the back, it's like floats. Floats is when you have a number with decimal points. A number with decimal points. But in this case, we can't classify this as, we classify it as float, but because it's not a single integer, that's why you see it as what? Double. A is denoted as what? Double here. So let's go on. Another way to read our data frame is to use Spark create data frame. Passing your RDD that we have here, RDD, which is here, pass this RDD into Spark. Already you know how we are reading Spark. Spark also Spark section. So we have Spark dot create data frame, passing the RDD, use to DF, and you pass in the column, and use asterisk to catch all the columns there. Then you run it, then we have our data frame. Still going to give us the same results. If you want to print schema, you can print schema this way. And you can also, instead of passing RDD here, you can pass in data value itself and do it to column. Another way. So you do Spark.create data frame. Then instead of RDD here, pass in the value, data value, which is this one, pass it in here and convert it to DF to catch the column of the data. And you still get the same results. Does that make sense?
Yes, sir.
Thank you. So now, we want to access some, libraries within PySpark here. We have from PySpark.sql.types, types, libraries, schema. We want to access, in this case, we can access the schema, the type of schema, and at the same time, the type of data, either in string or floats or integer or in any format whatsoever. So we can use this to, do it, and we can use it to convert to the type of, to data type that we want. So in this case, we have from PySpark, so we are importing this library, this particular module, which is sql.types, import struct type, struct feed, string type, integer type, float type. So don't forget, when we saw this one the other time, it was what? Double. So you can decide to get what? Double what? Double type. Can you see? It's popping up now. So double type, depending on what you want to do. So now, but this double type can also be float because it has the decimal point, remember? So you can use it as float type to still give you the same result. So we have our data. We've created this a tuple in a list. Can you see? We have tuple and we have a list around it. So here, so this is an element on its own. This is an element. This is the first one, second one, then third one. So now what we want to do in this case, so this is like we have three columns now. 3 columns of data, and we have row 1, row 2, row 3. This is what it means. Columns in the data, let's say, in this case, we have how many columns in data? 1, 2, 3, 4, 5, 6 in this one. This is row 1, row 2, row 3, row 4, like that. So that's what is happening here. So row 1, row 2, row 3. So in this case now, what we want to do here is that we want to create our data type itself. Because sometimes you have data without header, and you have to quickly identify the data type. If it's a string, if it's an integer, or if it's a float, you quickly need to identify it before you start doing data transformation. And this is what we call cleaning of data cleansing. So you clean your data first before you start doing other transformation within data. So you might see some data without header, might see some data that is no predefined data type. So you have to decide what data type you have to assign to it. Imagine you have an integer that comes with string, and you want to add, remember when we did what's it called? Z-loop and iteration here. Remember when we're doing add? Imagine a data, an integer that comes with string, and you want to, let's say there is no int here. You want to add it. It will be very difficult to add. So in that case, you're going to get an exception. And that's why, as early as possible, you have to start doing your data cleaning from the beginning. So in this case, we want to, we've imported this. We have struct type, struct feed. So we want to make use of that. So this is our value. This is the data that we have. Now in this case, all this. So we want to convert it. So for this LA code, we want to convert it to string type. This. For struct feed, we want to convert it to integer type, middle age. Sorry, for middle age, we want to convert it to integer type. Then for this, we call it level. We call it level 1, which is what? Let me see which one. So this is LA code number 1. This 210 is middle age. Then low is called level. So I call it level. So I assign string type as what? This is a string. The data type as string. This one is an integer. You can see it. I quickly convert to integer. This one as string type. So if we run this now, let me run the library. Then we've generated a schema value here. This is schema, because we assume that this data does not have a schema. So, and we need to assign a schema to it. So now, we now do Spark. We now create our data frame. We now do Spark. You already know how to get this one, which is this from here. Spark does Spark section. Don't forget, let me copy it so that. Okay, so let me highlight it so that you can refer, so that you can know, you understand what you just did there. So Spark here is here. I don't want to run it twice because I've already done that. So Spark.create data frame, we pass in our data value, which is this. I think I can do this. Our data value is here. I can remove that should work. Schema. What's our schema? Schema is this. So I think it should be fine like this. So let's run it and let's see our results. The fnew.show. Can you see? So it's either, you see, I deleted this. So it's not necessary. You can pass it in, but it's not necessary because it's going to identify it. You see, create data frame is expecting data. Can you see? That's what is expecting. Schema, which is this. If I go here, you will see the details. Schema is expecting data, which is this. Can you see? Oh, sorry. Oh, okay. Can you see there? So it's expecting data and is expecting schema. And that's what we've done. So I can decide to just, because we know the position, I can take this one off. I can take this on off and run it. I will still get the same result. And if I run this, I will get my data. Can you see? Early underscore code, middle age, level. And if I print the schema, we're going to get the expected schema because we've already converted it here. Integer type, string type, string type. So this is string, integer, string. So it's correct. Does that make sense?
Yes, it does, sir.
Is that okay, everyone? Please, if you have a question, because we're just starting this section, please ask.
Okay.
Oh, okay, okay. Let's go on. So now, I don't want to use this one. I've showed you how to, how to upload the file manually from here instead of using this. So it's not necessary. So now, I have this file called ukdataextra.csv. Let me look for the file. I think I have somewhere.
Excuse me, sir, can we also get that same file, that UK data .csv? Can we also get it, sir?
Okay, you want me to give it to you? Okay.
Yes, sir. To work with.
Okay. Yeah. Okay, I will see what I can do.
Thank you, sir.
But if you have alternative, that's fine. But I will send it to you. But let me see if I can. Can you all download it from? Let me see if I can do it from Zoom. 1 second. Okay. Okay, data for CSV. So I'm sending it to you on Zoom. Please download it from there. So I've sent it to everyone. Please download this. So
thank you, sir.
You're welcome. So now I have ukdata.csv here. I think I was trying to do something here. Yeah. So I have this ukdata.csv. So I want to read the file. So let me say, so I want to run this one now. So where am I? Okay. So now I've shown you an example how to get header, how to add schema and stuff. So I'm going to run this one now. Let me see the result I have. Okay. Okay. Just give me some seconds, please. Okay, so okay, good, brilliant. Okay, so I'm going to explain. Please don't be scared about that. So what I did here, I want to help you get familiar with how we transform data, and it's very, very important when it comes to Python. It might look a bit complex, but I think I will try as much as possible to break this down so that you understand what I just did there. So let me go here. But for the sake of people that are just starting, if you discover I've used this function, but I've not really explained how it works better, because it's like an advanced form of, Python, which you still have to know. If you see, when I was reading data frame and stuff, I was, should I say, I didn't really, I was just in Spark.read and stuff, and it's so easy. But I will explain a little bit about function. Let's say, for example, we have a function. In Python, there's something called function. You use this to read a function. And it helps you to be able to automate the process, to transform data and to reuse the code. And that is the reason why we actually use function. For example, if I decide to, you see, in this case, I don't know if you had, don't let me make it complex. Let me just start from it. Let's say df, let's say A equals to 1. Someone is, okay. So let's say A equals to 1, B equals to 2. Then I want to write a function to read that. So I can write function that says sum data A, comma bit. I put the parameter there. Then I will say return. I can say print, sorry, let me start with print A plus B. Let me run this now. Let me go to the next line and do sum data A, comma B. Can you see? But like I can do print around it, and I'm still going to get this. Does that make sense? So let me use print. So let me just do this. So can you see that? So I've added print here. So print is printing the results. So what we're doing there, we're doing calculation there. So if I use multiplication here now, so it's trying to do so 3 times 1 times 2 is what? Let's run it. Is it not 2? So 1 times 2, that's what this one is doing. 1 times 2 is 2. So if I do 1 divided by A divided by B, that's 2 divided by 1 is what? 0.5. Can you see? So that's what the function is just doing. We're not really doing something much. So we are wrapping up that, that function, and we're trying to make sure that we can use this code. So in this code now, this one is A and B. I can decide to say, if I want to reuse it, I can decide to use 3 and 6 in between. 3 and 6, you see the results. Okay, 3 and 7, let's say 7. If I run it, it will still give me, can you see the result? So even despite I've used 1 and 2 here, I can pass it another value here to still do the calculation for me. Does that make sense?
Yes.
Thank you. So now it's a way of, it's just it's a function that helps you to, do a lot of things, calculation. You can use your code. I can decide today, okay, let's say, for example, I can do plus now. Let me put plus here. and this plus A plus B is, let me run it again. Let's say this is 7, 7, 7 is, it should be 9, right? So 9. If I put 3 plus 7 in there, it's going to be 10. So if I decide to do this one as 30, it's going to add it, give me 37. Can you see? So you can, it helps you to reuse your code. So that's why we majorly use function like this in Python, and it's very, very important. So I've done something similar here so that we can reuse this code. So what I've done here is that there's nothing special in what I've done. And I've shown you an example. I showed you I only wrap up with, this function, and I call the name of the function read function. It's just read. So I pass in my schema. Let's say this is our schema. This is our CSV file that we have here. Can you see that I just imported? I uploaded there. So here, rather. So now I now call this Spark. Our normal read spark.read.format csv.option header equals to true, and I pass in this schema there. .load. Already we did this last time. So I pass in the schema here, and that's it. And I return this. I return data frame, which is this. So it's just like our normal data frame we've been doing. So it's still the same thing. So now we are reading the data frame. We're reading our data frame here. Here, I have a column that I want to add to this data frame. Let's open the file, UK data. If you see what I'm trying to say. If you look at UK data, it doesn't have a column, and that's what we want to achieve. Can you see, does it have a column? Can you see that? It doesn't have a column. If you see, this one has a column, right? This has got a column, so we don't need to add a column. So this one does not have a column. So we are treating this data as a data that doesn't have a column. So we want to add a column. I want to add a data type to it, and that is why we are doing this. So we are loading our data in UK data underscore extra, the one that doesn't have a column. We want to add a column to it. So we created a column for it here. And we have how many columns? 1, 2, 3, 4, 5, 6. So I created 1, 2, 3, 4, 5, 6, and I called the name, country name, country ID, middle age, adult age, elderly, teen. Can you see that? So what I now did next was that I used a function. I created another function and passing this list. I think we've done this. We have not really done something different from loop. If you remember the loop, remember loop? The only thing we didn't do here is that we didn't wrap it with what? Function. Can you still remember all this? Okay,
Yes, sir.
Brilliant. So let's go here. So we're just using a function to wrap. So there's no different here. If you see, if I comment this out now and comment this out, it looks like what we've been doing for this and this. There's no different. So, but we want to make sure that we read the parameter, we pass in a parameter in. So we need that function. I want to return something or print. So this is the column that we want to enter, we want to add. So we now do transform. I call this one transform. I can decide to use anybody. I can say transform SOM if I want. I pass in this column list here, and I created an empty list, which is called schema feed, an empty list. There's something you can create, an empty dictionary, empty list, wherever you can do. So, and I call this one for Tolulope. I think I was using someone's name then. So Tolulope in the list. Already you know what that means. That means for county name in the list, which we did, for county ID in the list, in the column list, for middle underscore age in the column list, for this in the column list, if Tolulope is in column list. Does that make sense? So let me change this one. Let me use column name so it can be confusing. Column name in column lists. So if column name, so I don't want to use development. So I'm passing to development here. So what I've done here is that I checked here. This is our column list. So I now did for column in this. Let me print seconds.
A quick question, sir.
Okay.
Yeah, the column list is the same thing as header, isn't it?
I'm coming 1 second.
Okay.
Yeah. This is schema feed. Yeah, it's the same thing as header. Thank you. Sorry. It's the header, which is the column name. Remember?
Okay, sir.
The
Thank you.
column name. Yeah, the column name. Thank you. So this is the header, is the column name, like schema. Remember the schema? So, but in this case, we want to add the schema type, where I want to add the struct type. So now, so we have here, I'm coming. So we have just want to. So now we have schema feed. So we want to do something interesting here. So I just want to print something. 1 second. Excuse me, one. Sorry. So now let's go back to this. So now we have our read function. We have been able to read the data. Then we have schema feed. So for this, we have our column list. Remember, transform column list. 1 second. So, so we have in this column list now, we have schema feed. So we want to loop through our column list. We want to loop through our column list. So we have, if column is this, I think there's a mistake somewhere, sorry. I want to try and figure out something there. Yeah, that's perfect. Okay. Okay. Oh, brilliant. Now, you see what is happening here is that we have a column list. So we don't need this. It's not necessary. So in our column list, we have Kansi name, Kansi ID, middle age, adult age, elderly, this. So what I'm trying to do here is to make sure that we group them separately to catch the one that has got the correct data type. You understand? But in our, I'm coming 1 second. Let me run this one. We have read function. Okay. Oh, okay. Now I understand what's on. Now, so someone is sending a message. Okay. Yeah. So what happened here is that we're trying to check through this list. We're checking if this for co in this, if co, so in this list is not, this one is not really necessary, but it's okay. So if co is already in a different list, so I should have another list somewhere, sorry. So let's do call new as a string, string list. Brilliant. That's good. So let's say we have a string list. In this list, we have anything related to string, which is this. Let's put it in. So I just created this one. So I think I remember just putting it there. And so we have, this is a string, right? This is a string. So we have this one as string also. Then we have this one as string. Okay, we have others. Yeah, so we are good now. So now, so if co in string list. So now look at it. So here, what we're trying to do is that we want to separate those ones that are string from those ones that are integer, and we want to create a schema. That is the idea here. So here, if I run this, transform, I think that might be an error. Okay. So if I run this one now, look at it very well. If I run this one, so what is happening here is that it's going through this list. It's going through this list and it's checking one after the other if column name is inside there. If column name is in a string list, it should convert it to string, because we decided to say, okay, this is the string that we're interested in, because this is an alphabet, right? Numbers. So this one it can be string. It's string already. This one is integer, or numbers. They are integers, double type or float type, whatever. But in this case, it's double or integer. So we want to make sure we separate them and append them and add the expected string and the data type. So that's why you have here, I created an empty schema feed and I pass in the column list. And I said here that and I said for column in column list, if column in string list, if it's in this list, right? Then I said schema feed, if column is string list, we want to get it as string type. Schema feed dot append struct feed, column name, if it's there, convert it to string type and call it true. Else, if it is not in this list, that means it's an integer. All these ones are integer. Then append it as what? Integer here. Does that make sense? And after appending, then can you convert, pass in the struct type and pass in the schema feed and read the function? Does that make sense? So now, after doing that, we've already gotten, now, after doing that, we've named it as schema type here. So this read function now, we now pass this function in here so that our schema will pass into the schema that we've generated here. And I'll print the schema so that you can see it clearly. Let's do it. Let me see if I can. Schema on the side. Can you see the schema now? It's printing it out. Can you see it's assigning it to the right? Now let's see it from the beginning. Can you see? Can't see string type. Can't see, we expect to be string type from what we have looked here. We said it should be string. Can't see ID, it should be string. The middle age should be what? Integer, because we've already said it should be integer here. The adult age, which is this, should be what? Integer. Struct feed, elderly should be what? Integer. Can we all see that? Is that making sense? And if you move down, teen is what? Integer type. Does that make sense? So we're looping through the list, and we are saying if list is string list, if it's here, make anything here as what? String type. Otherwise, any other thing that is not here should be what? Integer type. And if it's integer type, create the schema. This is the schema that we are passing in now. We pass the schema to our read function here, and read function is passing to schema here. And we are able to get our data. And if we go further now, if you do print schema now, so here I can decide to do, let's say, df underscore new equals to read function. Can you see? Sorry, I can pass in read function here and do return df new. It's still giving me the same results. So df new is here. So it's still going to give me the same results. Can you see? It's still going to give me, so I can decide to click now. Can you see? So here, don't forget df new can also be used here. I can decide to use df new here. It will show, it's still going to give me the same results. Can you see? Oh, no. Oh, so it's reading another df. Let me run this again. Let me run this dff, okay. Read function is going in as df brilliant. Df. Okay, so I think there's a mistake somewhere, sorry. I know the reason. So let's return back to our normal format. So don't let's return the function directly. So which is this, and we've been able, the reason is that we're passing in the schema here, and we're returning this, and we can run our data frame. Can run our data frame now, which is now that's read function, which is transform. We can say df equals to transform column, or dff, or whatever we want to do, dff underscore new. Let me call it dff underscore new equals to transform column. Can do dot show, doesn't matter. So we can do dot show. Can you see it? And you see the reason why this one is printing is this. So if I take this off, it's going to disappear. So if I run it, it's gone. So I can do df, like I said, the oops. So I can do df underscore, let me say, it's just a name, please. Don't get it wrong. It's just a variable name. So if I do this, then I can run this one separately as dff underscore new dot show. Then I can print schema now if I want. So let's print our schema. Let's print our schema. Dot print schema. So let's print that. Can you see the schema now? So it's coming out as string as expected. integer, 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 integer. Can you see how we are applying Python in Spark now? So, and that was what I was trying to explain to you. Looping, for loop, conditional statement. We have applied for loop, we have applied conditional statements here. This conditional statement, if S, we've covered that. And we've been able to do all this stuff within using Python. So all these ways you can now transform your data. There's some other things we can do when it comes to data transformation also. So you see, so it's so easy to transform data if you understand how to use Python within Spark. You see, so in this case now, maybe you might have other data similar to this. Maybe in a case where you have another data, which is the CSV file, which is CC here. In this case, you can pass in this one here. Or you can create another function to say, if this is this, do this. You understand? If this is this, do this, and it will do it. So you can use it to classify. Let's, for example, we're expecting. Okay, brilliant. I think this is a very good idea. So for example, we have read function schema here. We said this one should do transformation. If our data comes maybe in a multiple file, and we want to read it, we can decide to manipulate this, you understand, to read those data differently. And we will still use it in our, within our function. Let's say, for example, we have two different data coming in now. Let me do it this way. But in that case, we cannot use the whole code like this. You can use this one here, and you can create another code, maybe to do something else. Does that make sense? So for example, let's say we're expecting UK data CSV, and we are expecting another UK data. In this case, you have to create your data frame separately, but you can still use this one. You can decide to manipulate this one to do something different, like if, okay. So this is your file. Okay, so let's see. One second, please. I'm doing something different here. Let's see. I think we can do something that I'll find a way of doing it maybe later. But you want to loop different files. So within the Google Colab, I'll find a way of doing it. So we can decide to read, these two files and, read it, then start looping it separately and read the file separately. So there's a way you can do manipulation of data. That's why I mentioned last time that when it comes to transformation of data, you need logical thinking. You need to, logically think, how do I apply this? For example, I'm applying this. I want to apply schema to this now. See how I play around it, and I was able to get this, and I was able to convert it. So that's that. Let's just put that aside. If I have some time, I'll be able to explain some other examples. Well, we still have a long way to go. So now we've been able to print our schema. Can you see the example there? Print schema. And so I call this one DFF now. So DFF here, let me pass in as DFF here. So DFF here now, print schema. So I can, oh, sorry, we've done that here. So let me put this one here. DFF here again. So if I run this one, now we want to get the number of partition. And you see the partition is 1. So it's a whole file. The meaning of partition is that when the file is being transformed, how many, I was explaining, if you remember when I was talking about SPA, I talked about worker node. If you remember, master, and I was talking about division of labor, that if one person can do one job in 10 hours, how many people can do the same job how many people can do the same job in 1 hour? And you said 10. The 10 people can do it within 1 hour because they can divide it within one another, between one another, within one another, and get the data, get the work done. So in this case, it's only one person, just like one laborer. So if I want to repartition this one out, I can do, okay, I want 2 people to do the job. I can pass in 3. So I want the data to be processed in 2 places. So let's say A3, let me write 3. Let me put repartition here. Let's get the number of partition. Oh, DFF, sorry, this is the partition. So pass this data frame in here, DFF underscore new. So let's run DFF gets number of partition now. So let's see what we have. Oh, it's still giving me one partition. Okay, so I want to know the reason why I'm getting one partition. New. Okay. Oh, convert to RDD. One partition. Okay, let me try 2. Okay. So I expect it to give me another partition entirely. But let's see, let me see what is happening. Maybe it's not grabbing it here, but let me see. So I expect 2 partitions. So this particular file now, we can write it to header equals to true. Then I can rename the file, the output. I can write this one as output file. Let me do output file SOM. File SOM. Let me rewrite it now. Let me write it. Let's see. Oh, it said RDD does not have a rights. Okay. Oh, okay. This is the reason. So now let's do it again. That's it, all done. So let's go here. We should be able to see output file SOM. Can you see output file SOM now? This is the CSV file that we just converted. So if I download it now, I'm downloading it now. So we can see our CSV file transformed. So can you see the header now? The header name. Initially, it doesn't have header. Remember, it was UK data extra, no header, which is this. But now it's got header. Now it's got header. Can you see? There's no different header. UK extra data, and this is it. Does that make sense? So that's the example. I think we've covered a lot. Any question? Any questions so far? Any question? Everybody's quiet. Any question?
No? Okay.
Please, if you have any question, ask now so that I can go back. I know it can be complex, especially when I start using function. Please take me back so that I can explain better. Okay. So
Okay, hear me.
I can hear you now.
Okay, so I think for the purpose of others, I think maybe you've shown us how to add the column. So can you show us how to add the rows in an already existing data set?
In already existing data sets.
Let's say, for instance, that you are manipulating a data set and you think that in the position of cleaning, you know that there's a row that will really be important for you to complete this analysis. So you want to add an extra row either to the left or to the right, whichever way works.
Yeah, you can do that. We can do that. But along the way, I will show you that. But do you understand what I've covered so far? Because we see our other parts, then I can push that one in along the way. Do you understand
Yes,
what I've covered so far? Okay, that's good. So let's continue with the I'll be covering this. Let's see. Successfully. Okay. Good. Let me run this. Hopefully, it should work. 3.5. So we're going to go to proper Spark now. What we need to understand is Spark very well. But what I did there was just to show you how to manipulate the schema, how to add schema. You know, you're talking about how to add data or something like that. In this case, I'm just adding schema. So you see how I'm going to add data to column in this next part of data frame. So I'm going to run this again. I'm going to so that's the latest version of Spark. So we need to revert after the latest. So I'm going to run this again now. Run apt-get. Oops. Okay, that's fine. So already we are familiar with what we cover here. Please don't be scared with this. This one, all I did was just to ask schema. We didn't change any data. I just showed you how you can, use your Python experience to add schema, this schema and determine the data type. And that was what we just did here. So in this section, I will break down everything you need to know in Spark. So, but please, don't just watch the video, practice. If you don't practice, you will not understand this thing. I keep emphasizing on that. If you practice, if you go, and that's why I don't want to send you a copy or PDF. Go to the video, stop the video, pause it, then start watching, go through everything step by step. But I'm very, very sure you will find, you will make a mistake, that one is guaranteed you will make a mistake, go back again, try it. Before you know it, you will understand it. Like, oh, okay, this is the way to, do stuff, So now let's go on with this.
Sorry, sir.
Yeah.
Sorry, sir. Please, if you don't mind, can you please take us through how to have the schema again, please?
How to what?
How to have the schema again?
How to add the schema? Have you been
it, yes, sir.
Have you tried it from your side?
No, I haven't.
Why are you not trying it? I think you have the data already.
Yes, it's because I just want to concentrate to understand it. Then it's always easier for me to understand it. So when I am on my own, I'll be able to go through it and I will have less problem going through it.
But we have a recorded section. So
okay,
I will advise, just go through the video. Now you have the data,
sir.
the no header data, you have it. Go through the video, try it. You'll be fine. I'm very, very sure you'll be fine. And remember, I showed you an example of function here. How to add,
I know it's very easy, but
this one, you use function inside the function. If you see, I use this function inside this function. So the result you are getting from here, okay, let me go back. Whatever you have done here, this is, you are pending this, you are pending everything inside this list, right? This field. So this, everything you have appended in this field, you pass in the struct type to catch the data type you've already assigned. Then you pass it inside the read function, which is the other function here. So the read function, the schema is now passed here, which goes in here. So here is like we are putting this one inside this. You understand? So we're pushing this schema, wherever we have generated from this, from these results here, from here to here, which is schema data, we now pass into the new function at the top as schema data. I call it schema here. That's why I say it's reusable. Remember, I said the function can be reused. A function can be reused. So in this case, you can reuse the function. I can reuse this function as in multiple times. I can create another Python script to use this function, but not this one. And I will map all of them together. So you understand? So that's the idea. And that was the reason why I took my time to explain for loop. I took my time to use to explain conditional statements so that you understand what we have to do, how we use it to manipulate data, how do we use it, The only aspect I didn't emphasize on is the function. And I will advise you, please go and read function. Go and read function. I won't cover it here, it's because it's more advanced. But there's no way I can teach you high level of, Python, how to transform data without talking about this function. But please go and read more. I will advise you go and read more on function. It will help you so much. If you want to do complex transformation, reusing your code, you need function.
Thank you, sir.
You're welcome. So let's go on. So here, in this example, the previous example that I just covered was all about no header data without schema. And we added our schema and we added our data type. That was what we did there. We added schema and added data type. So, but in this case, we have our data with schema, and I have it here, which is UK data. Can you see the schema is there? It has a column name, which is the schema header, LA_name_code with. So that's that. So now we want to read this data now. Let me see if I have the data here. Oh, I don't have it. So let me import it. UK CSV. I think I should have it here. Brilliant. So I have it here now. So let me go back so I can run CSV now and count the rows there. So it's loading now. Let's see. So now, let me print the schema. Can you see the schema? That's the data, the same CSV file that we're having. So when it comes to reading data, we assume data is stored somewhere. An example of where our data is stored is here within our Colab, right? So our data can be in S3, could be in S3 buckets. It could be in a database. It could be in another storage. So you have to understand that how do I read this data from that particular location? In our case, it's just within the Google Colab. In other cases, could be S3 buckets. How do you now read data from S3 bucket? So it's very, very important you figure that out, how to read data from S3 bucket, like S3, or you have a data lake in Azure platform, other platform where you save documents, you store your document. So you have to understand how to use Spark to read data from there. But example I'm giving here is just within this environment. And if you are using IDE such as PyCharm, if you are using, please, some people are familiar with PyCharm as IDE to deploy their code and stuff. You can use that and read data from the environment. So you can also try it in that environment. So now, here we have read as file successfully. We have it. Then we count it. We have 323 there. We have in rows. Let me check it here. You see this, the same thing. If you're familiar with Excel or CSV, you click here. How many did you see? 324, including the header. So if we exclude the header, you have 323. So it's still the same thing. So everything is perfect. So we have 323 here. So it's correct. So let's print the schema. Printed the schema. We want to get the number of partition. Then here we are using coalesce. The coalesce to make sure that the file is not divided. It's a better way of ensuring your files are all together. But as a result of parallel distributed system of Spark, sometimes files are bigger. Spark will split it into different parts, which means, you remember the nodes, they divide the job among themselves and they do the job. So while they are dividing the job, they will split the file into different, parts. You understand the logic? So that's the idea of the master, the node, the worker. You understand? But for us to collate all the files together, we just use a coalesce and we pass in one, and we get our data as one single file. And here, I was talking about the partition the other time. So here we can have this one here. I think, so let me do again on partition. Okay, that's good. So let me do. That's the reason why I didn't get it the other time. I was doing something like this the other time and I couldn't get it. So let's say I want to divide this file into 3 now. If I do this one and I run it, can you see? It's going to be 3. That was what happened the other time here. When I was doing print repartition, I should have used here. When I was using repartition, I should have used this, right? So to get the data separately. Can you see? 2. That was the mistake I made there. So you see? So we are getting it correctly. Now that we've done repartition as 2, if I run this code now, the file will be 2. Look at it. I will run it now. You see it's going to be split into 2. Okay. It's saying already exists. So let's change the name. Let's change the name. SO. Let me change it to SO. Now let's see. Let's see the file. SO. Can you see SO? Let's open SO. How many files do you see? 2. Because we've already used repartition as 2. Does that make sense? Does that make sense?
No.
Last time, the previous part before I moved to the other side, I was talking about, when I converted the schema and I printed the schema and I wanted to get number of partition, I said it's 1 here, right? You remember? So
Yeah.
now, 1 second. So it's changed there. Let me do. Okay, let me run the old stuff again. We'll explain again. So SO. So I explained that why after we've checked our data frame, we can get the partition. And I explained division of labor. Remember, the division of labor is done at this stage now. So let's say the whole file is 1 file, or maybe it's 20 files divided into 20. You can decide to reduce it to 2. You can use coalesce to make it as a 1 full file. Okay, let's keep running. Let me go back here. For example, this file is the one file now. When we run this particular code, we got 1. So I want to repartition it. Repartition is that it's going to split this file into 3. Just like here. Here, I use 2 to split the file into 2. So if I split the file into 2, we're going to have 2 files here.
Like it's going to create a double of that file.
No, it's not going to create double. It's going to divide this file into 2. You know, let's say this is the whole file now.
Yeah.
So because we are using repartition, it's going to cut it into 2 and push one in one CSV and the other in another CSV. Let's see.
Okay.
Let me download it so that you can see.
Okay.
So that you understand what I'm saying. Let me download it. So E6014D09. So let's see. Let's download. Oops. Okay. Okay. So look at this file. E6014D09. This is the file. And that's the first one. Let me check the other one. Okay. Oh, okay, sorry. This is the second one. Okay. E6014D09. So let me go here. Download E601. So this one is 9500B 539, and this is 5394. So I'm not sure which one, but let's try this. Okay. Okay, it's open. So I think they are opened. So let's see. Let me do this. Yeah, so see the file. Are they the same? Look at it very well. Are they the same? No. Look at it.
They're not the same. One is from 1 and the other one is from 16.
You see, this is 1. Look at the bottom, arrow gates. Did you see arrow gate on this other one? So it's been divided into 2. Look at the column. How many? 162. Look at this. How many? 162. But normally it should be 3 what? 323. Remember? So it has been divided into 2. Does that make sense?
Yes.
You understand what I mean? What I mean is that if you look at the count of the whole file itself, yeah, this is the file that we use now. Where is the UK data extra? You know, we use this UK data extra. If you count it, is what? 323. But when we apply 2, we divide it into 2. The one was 162, the other 162, right?
Yeah.
You got now. You understand what is happening. So that's the repartition part. It's going to split the file into 2 when you are saving it, storing it.
So why should we split it?
Not that you intentionally want to split it, but sometimes when you use repartition, it increases the performance. The speed will be very high, but mind you, it goes with a cost. Especially when you are working in the cloud environment, it's either it's costing more.
More space.
No, not more space. Yeah, more space. Thank you. Brilliant. Not more space. It's not more space. No, not more storage. But the major aspect of, in terms of cost, the efficiency has increased, but especially in the cloud environment, when you're using repartitioning, it's more faster. It's like you are saying, naturally, a system within Spark will divide file if it's too big. Like I told you about parallel processing. You know, I was talking about parallel processing. So when a data is too large, Spark, using the Spark context, remember, the master, it will divide the job within the node, all the nodes, and they will process the job separately, just like division of labor, 10 people being allocated to a job. So if those 10 people are allocated to the job, what will happen? They will process the job separately, right? If I'm making
Yeah.
sense. So automatically, we are going to have how many files? 10 files. Does that make sense?
Yes.
And that's the idea behind this Spark. So when you're writing file, but sometimes you want your file to come together. You want all your file, instead of being divided as a result of the file being huge, you want your file to come together. That is where you apply Quelless, which is this. So you put one there to bring all the files together. Does that make sense now? So in this case now, I can, I use repartition. I can now change this one. I can decide to change this one to Quelless now. So if I use that one, it will turn my file to, let me say, if I use this, it will turn my file to 05. Look, 1. It turned it to 1 instead of 2 before. Remember, it was 2 here. So if I run this script again now, let me put another name, SOOO. Let's run it, you see. Now, let's check. Let's open it. SOOO, do we have that? Is it there? So, look at it. How many files do you have in? 1 instead of 2. 1, only 1 file, which is this. And if we download it, you see it's going to be 320 something file instead of 162. Let's check it. This is the file. How many? 323. Can you see? The whole file instead of 162. So you see the idea now, how you can, so you can use that Quelless to bring your file together. But one thing about Quelless is that it put the file together, it will slow down the process. So it could be asked in an interview, what's the difference between the repartition and Quelless? What's the disadvantage of, what are the disadvantages of Quelless? What are the disadvantages of repartition? So you'll be able to explain that repartition helps you, like in terms of advantage, it helps you to process your data faster by splitting all the files, and but in terms of cost, it can cause company to incur cost because it's faster. Look at it this way: you have one person to do job, you are paying the person £10,000 to do the same job, and you now say, "Oh, this job is going to be slow, and I want it to be done within 2 days," and you now hire 10 people. Does that make sense? That means they say you are paying £5,000 to each. How much are you going to spend? 50,000 instead of 10,000. Am I making sense now? Because
Yes.
you want to buy time now. You want to make sure they quickly do the job. That is the repartition. So the time for Quelless to work is going to take time for the whole time. Let's say, for example, instead of, if you use repartition now, maybe to process your data is going to it should take like 3 minutes. If you use repartition, if you use Quelless, it could take like 5 minutes, additional 2 minutes, because you are only assigning somebody only 1 file. Okay, let's go on. So we have Quelless. I've explained that. Then now, the next part of the work is, I'll try and rush this one, I think. So we have in Python, in Spark, we have something called selects. And for you to select, you can select a data frame. So remember, we have our data frame as data_df. Data_df. So we want to select this data frame. We can do data frame, data_frame.select. What's the column we want to select? We have the column as middle age this. So we want to select only 3 columns out of it. So we can run this one and select our column. If we run data_select 1.show, you will see it's going to show you few columns instead of the whole column. Look at that. Only 3 columns that you have selected. So it's just like a select statement in your SQL. Select my middle age from this table, database.table. Someone called Koblo Usani.
Yes, sir. Sorry to take it back, I think for the repetition one, can we still apply this using pandas? Because I think maybe there is a limitation with pandas and the PySpark concerning the repetition, but I don't know from experience if we can try to apply that using pandas.
We're treating Spark. We have, I would have loved to cover pandas if time permits, but this is Spark data frame, and Spark and pandas, they do similar work when it comes to data transformation, but you use Spark for more like large data sets, very large data sets. So I think repetition for pandas, yeah, it's possible for pandas, but I've not really used repetition for pandas. I've not. Even my current projects, I use pandas, but I've not used repetition when it comes to repetition. All I know is that when it comes to data transformation in pandas, all the files goes in directly without being divided. I've never seen any division since I've been transforming data with pandas. So I don't think, I've not tried repetition, but when it comes to Spark data frame, but because Spark data frame is parallel, it processes data in parallel. So I think that is the major reason why we use repetition in that. But someone is raising hand, they got Koblo Usari. So I've not tried within pandas, and since I've been transforming data. Hello?
Okay. When I'm using that, I can manually split. So I was thinking if it's possible. I think the PySpark is automatically doing it even without you giving any code for it.
Thank you.
So I was thinking maybe the same thing is applicable.
Exactly. That's what is happening with PySpark. I told you parallel processing. PySpark will intentionally divide the work. Some work that you can, do with pandas, PySpark will undo it. It will speed it up and will process. It will split the data and get it sorted as fast as possible. You see the difference between pandas and Spark now. So, but they work hand in hand. You can do Spark pandas data frame. You can convert data and start transforming in pandas, then take it back to Spark. So within this Spark data frame, you can do a lot. You can do a lot with pandas. You're welcome. So here, for example, okay, let's run this one. So we're selecting this, we're selecting this. You can decide to do this one to pandas, right? Like you said, to panda. So goes to beta underscore select to pandas. So you can convert to pandas. So to pandas now, you can read your data. Can you see in pandas now? So this is that, you see, you see the index in pandas. So you see, you can, like in this case now, you can start doing transformation in pandas. You can do a lot here. So Spark is so flexible that you can convert to pandas data frame. You can take it back to Spark data frame. You can use Spark SQL. You can do a lot of things within that space. So it's so flexible. So you can see to pandas and you can do other transformation if you want to do anything. So let's go on. So I've shown that example. So now we can also select, when it comes to select, we can do data frame.select and pass in the data frame and the column name here like this for select. Can you see? We can do that. We can now show it. It's still going to give us the same result. So I'm showing different examples of select. You can select this way, call, middle age, call, pass the call inside, or at the same time, you can just select this. You can use select, middle age, comma, this, and you can go to another form of select. You can do select, call, middle age, comma, call, middle age, call is column. Then call adults, you understand, you do that. adults, children, adults, so children. So you can do that and you select. You can also select using the data frame dot the column name, data frame dot you use data frame dot select, data frame dot column name, data frame dot column name, data frame dot column name, and you run it, you select. So you can do now. Remember when I was using start and end in our what's it called when I was doing list. So here you can select column this way. Does that make sense? You can use df select data dot column. Can you see? You can select column. I want to select only 4 columns now. You can do that. And also, there's another thing you can do with data. Let me do learn data underscore df dot columns. So let's run this now. What you do see here? You see, I was talking about, if you remember, I was talking about using len the other time. You know what this is doing? If we go back to the beginning of our code, we have 6 columns, right? 1, 2, 3, 4, 5, 6. So here, with our len, we can capture the columns that I want to transform in a data. For example, there's some data that a user can actually, a user could make a mistake and add an empty space, which the data will just assume there is a column, there's an additional column. So in this case, you can use like len to grab. I was talking about len the other time. You can now do if len, you understand? If len, this is greater than, len this. If len this is greater than 6. You understand? Because already if you see from here, we know that we're expecting 6 columns here. So you can do a lot of manipulation using, you see 6 columns, 1, 2, 3, 4, 5, 6. So if it's bigger than, maybe larger than 6 columns based on 6, you see when we ran the len the other time, it gave us 6, right? So I can say if it's greater than 6, that means just catch the error. You can do a lot of things when it comes to data manipulation, but I think I diverted a bit. So let's go here. Here, we're using this one to capture how many columns? We're capturing column 0, 0, 1, 2, 3, index 0, 1, 2, 3, which is column 1, 2, 3, 4. So we're capturing that, and this is it, using dot columns. A lot of times I use the dot column a lot, dot columns. It's very, very important. Dot columns, I use it a lot when it comes to data. And that len that I showed you, I also use that lens. So we can use this one to select. So let's go on. Then here, we can check the, use this one to check the, to convert to the actual data type, like I showed you in that first one using schema, printing the schema. So here you can decide to use convert the data type. For example, this one is middle age is in string. We expect the middle age to be integer because it's number, isn't it? Look at it, it's number here. Middle age should be number. But when we printed the schema, here, it was giving us string, so we have to cast it to integer type. So you see, I now pass in, I say data underscore df dot with column, middle age Then the data frame itself dot middle age dot cast. So this cast, oops, dot cast integer type. Then I've changed this middle age to integer type now. I now did another one, dot with column, children. Then this is the column that I want to change, comma, data underscore df dot children dot cast integer type again. So I did it for all of them. So for young people again, I cast to what? Integer type, and adults to what? Integer type. And after, you see, the previous data type was string, 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 all of them. So, but when I now try to cast them, now after doing this, you will see we are going to get a different integer data type. Can you see? String, string, integer, integer, integer. It's similar to what we did here, remember? To what the transformation we did here, that is no different. But in this case, there is no specific schema added. But in this case, we have a schema, but we just need to convert the data type. So I just use the integer type, integer type, integer type. Please go and practice this, do it line by line. And can you see? So follow that step and do it line by line. So when I printed the schema, I've got the actual expected schema, which is part of the data cleaning of data. So if I run it now, I have my full data frame. So here, I want to cast, I can decide to cast middle age to float type, If I want, here, already know that middle age is integer, but I want to cast it to, I can even cast it to double. Let me see if I import double. So this is double. Let's copy double. Let's copy that double. Let's push it here as double type. So I can convert it to double. Let me run it and let's see the results. Can you see? Middle age has turned to double. From integer here, because we apply the double type, dot cast double, is giving us double. Already we know it should be double. If you convert it to float, it's going to give us 0.0. But in the data, we can see there is nothing like floats, no dots there. So I think it's better we use double. So if I run this one out, it's going to give me, what is it giving me? Okay, so I think it's giving me that anyway. I'm seeing it as floats now because it has dots. So now let's go on. So I can also rename the column. I can rename our column. And for me to rename our column, there is something called with column renamed. With column renamed. With column renamed. So with column rename helps you to rename a column. So for example, our column here is LA_name. So these are I'm just using this variable name. Don't forget you can use any name here. So change data type _df, which is here. 1 second. Change underscore data type. So we're using this one. Don't forget, change underscore data type underscore df here. Then dots with column rename. So I want to change the name from LA_name to LA name. So this is the old name. This is the new name. Old name, position, new name. So if I run that, I have a new name. Can you see LA name? LA name there is been changed. So I can decide to change the name again. Let's say name, and do name. If I run it, it's going to change the name. Can you see? LA name. So use this one to change the column name. I can decide, I can add an additional column, just like my friend said the other time. I can add additional column, but for me to add that, I can use leads. There's something called leads, but I want to create, this is called add coding. You want to add code the value. So I can concat, I can join also. So we have leads, and for you to access that, you compile spark.sql.function import leads. This one is to create a new column, add coding concat to join. So if I do that, change data type underscore df equals to data underscore df dot with column. We have data column now. This is the new column I want to create. I want to add United Kingdom to that column. So I'll put that leads there and pass in United Kingdom. And if I run that, let me run this one because I've done. Can you see? So I can do London, United Kingdom. It's going to change now. London, United Kingdom. Can you see? Can you see? So that's it. So if I want to concat also, if I want to concat now, I want to create another column for concatenation to concat. So I'll use change data type, which is our data frame that we're using, dot with column. The new column that I want to create, concat. Can you see the concat? This is the function concat that we have from here. Concat, the data frame. What do you want to concat? That the concat means that we want to join two existing columns to give us a new column. Two existing columns to give us a new column. So, and that means we want to add concat. So lit will help us to join to create what we want to put in between, like this, and the new column, the other part of the column, data column, which is this. So if I run this one now, you will see here, we have concat. It's going to show. Can you see? London, United Kingdom, we are joining this column with which one again? LA name. So we are joining this one and this one together to give us what? This concat column, which is this. So that's concat, how to use with column to concat to join data together, concatenation, and that. Do we have any question? Any question? We're going to quickly finish today by 4 o'clock. I'll be rounding up the class. So we have 4 minutes now. Please, if you have any question, please ask. Any questions so far?
No, please.
Okay. So do we all understand everything? Okay, that's
Yes,
fine.
by going back to practice and master the functions.
Please master them. Go back to the video. That's why we have that video.